Let's focus on applications for a second. Video shouldn't be too long. One of the big things for applications is, what are the units? Is our answer in miles? Is our answer in liquids? That's not really a unit at all. Gallons? Is our answer in thousands of millions of cubic feet? Because we're talking about the flow of the river in feet for some reason. How do we find units? Well, remember, for derivatives in chapter 2, if we have a graph, the units of a derivative are the units of y divided by the units of x. Why? No pun intended, because derivatives are slopes. Slopes are rise over run. Change in y over change in x. So the units look like slope too. So integrals, the units of a definite integral are units of y times units of x. And you can remember that integrals are area. What's area? Area is x times y. Or you can just use your notes. But that's the idea here. This is area, and you can think of an area of a rectangle. So I didn't want to scroll back to see what example number I'm on, so we're on example something. Oh, marginal revenue. It's been a while. Not that long actually. It's been like a section or two. Suppose that marginal revenue is written as a function, MR of Q. And marginal revenue is going to be given in dollars per item. And MR of Q is that marginal revenue for selling Q items. The question is, what does the integral from 0 to 150 of the marginal revenue function with respect to Q, what does that integral equaling 1,000 mean? Whoa, there's a lot going on here. Lots going on here. Remember that the definite integral of a rate of change is the total change. What do we have here? Is marginal revenue a rate of change? Well, using kind of the official business one, it's not really. Marginal revenue is just the extra revenue of the Q plus 1th item, the next item at a production level of Q. But remember how we found marginal revenue in calculus. That was the derivative of the revenue function. It is a rate of change. Specifically here, we have a rate of change of revenue. Marginal revenue is how revenue is changing because we find it with R prime of Q. Again, we find it with R prime, so it is a rate of change, but also conceptually, marginal revenue is also something a little different. The extra revenue from the next item at this production level. But this is going to be useful. So this definite integral is the total change. Again, it's the total change of revenue. What do the limits of integration mean? Well, it's the total change between A and B. So we're going to have the total change of revenue between 0 items and 150 items. How can we write this in a normal non-mathematical sentence? We have the integral of a rate of change of revenue. So this integral is going to give us the total change in revenue between 0 items and 150 items. What's the change? The difference. Ooh, maybe we use that word. Instead of change, it could be difference. The difference in revenue when we produce 0 items and the difference in revenue when we have 150 items. Well, that's just there's no revenue when we don't sell any items. This will just be the revenue of the total revenue of selling 150 items. In other words, the revenue selling 150 items, and again, technically it's the change in revenue between selling 0 items and selling 150 items. But in this case, selling 0 items doesn't have any revenue at all. So we can simplify it essentially. The revenue of selling 150 items is, 1,000. And what are the units? Well, what are the Y units? What are the units of marginal revenue? Marginal revenue is given in dollars per item. Dollars divided by item. The units of a definite integral are the Y units, which is marginal revenue, dollars per item, times the X units. What are the X units? Q is in items. When we multiply these, what do we get? Just dollars. So the interpretation here is that the revenue of selling 150 items is $1,000. In other words, let's really connect everything. The derivative of revenue gives marginal revenue. The integral of marginal revenue gives total revenue. Derivative of total revenue is marginal revenue. Integral of marginal revenue is total revenue. They undo each other. Integrals and derivatives are basically the same thing, just going opposite directions. All right, this is how we can use it. Let's do another example. Example something plus 1. Whatever example the last one was, this is the next one. Suppose that R of t, some function that's given in centimeters per year, represents how the diameter of a tree changes with time. What does this definite integral mean? Similar problem, but not the same. Remember, the definite integral of a rate is the change from A to B. Oh, I wrote off the screen. From A to B. Well, what does that mean here? The definite integral of a rate, what is our rate? How the diameter of a tree changes over time. Diameter change over time. That's our rate. And that's the total change of what? Well, this is diameter changing over time. This is going to be the total change of diameter of that tree. What are A and B? I don't know, some time 1 and some time 2. So that's what this shows us. This integral represents the total change or total growth, whatever word you want to use, of a tree's diameter between times t1 and t2. So maybe t1 and t2 are 5 years of age and 10 years of age. Who knows? But this, whatever this is, right? In the last example, I said this is equal to a number. Here, this is going to be equal to some number, but now we don't know what it is. This integral does represent whatever this integral equals, because it's a definite integral, it will equal a number. And that number that it equals is the total change or the total growth of a tree's diameter between these two times. And that's how we can interpret these integrals. What are the units here? It's always the units of y times the units of x. So the units of r of t were given in centimeters per year. Unit of x is time. It didn't actually tell you, it should have, that time is in years here. We're always going to get cancellation like this when we deal with rates. You just have to be very careful. Just like that first gnarly example from this whole section with the flow of that river, you do have to make sure your units match. It's going to be the total change of growth of a tree diameter in centimeters. Because once the years cancel, we're just left with centimeters. And that's what we've got here. Let me know if you have questions about these ones. We do more applications later. We're going to be sprinkling them in all the time. This is one way that we can use them, and a little confusing, I understand. Do some homework problems in the video after this. So I would recommend, again, as a reminder, do the online homework and then try the paper homework. And then if you do want some more practice, or if you get stuck on those paper homework problems, watch this next video. Or you could watch it after you do them as well to see how our methods compare. Have a good one.